In Chapter 10, we continue to look at quadratics, and in particular, we're going to look at quadratic equations. And for the first couple of sections, we'll start out by graphing them and see what they look like. So in general, we're going to have a form something like this that says y equals ax squared plus bx plus c. We've already dealt with the right-hand side of this equation. We've done things like factor this when possible. And now what we're going to do is graph this, and we'll find that when we have an equation in that form, it will graph as a parabola. And when we look at a parabola, we're interested in several parts of that parabola. In particular, where is the vertex of the parabola? And this will depend on the values of a, b, and c. Does the parabola open upward or downward? This will depend strictly on the value of a. And then also, relatively speaking, how wide or narrow is the parabola? That will also depend strictly on the value of a. Okay, and in this section, we're going to look at cases only where b is equal to 0. So when we have that y equals ax squared plus bx plus c, with b equal to 0, that x term drops right out, and we end up with only ax squared plus c, and that makes things a little bit easier for us. So how do we graph these? Well, one way to do this is to complete a table, and that's what we're going to do in the first example. So the directions say complete the table for each equation and then graph each of these on the same graph. So we want to put these on the same graph in order to compare them. So in our first case, we have y equals x squared. This is a basic parabola. This is sort of the starting point for other parabolas, other equations that will have some additional features. But for now, let's just go ahead and take these values of x, square them to get our value of y. So when we square negative 2, remember that's a negative 2 times a negative 2, so we get a positive 4. And when we square negative 1, likewise it's a negative times a negative, we end up with a positive 1. When we square 0, we get 0. 1 squared is 1, and 2 squared is 4. Notice the symmetry here. So 4, 1, 0, and then right back up 1, 4. And that is one of the key points to a parabola, is that a parabola will have symmetry to it. So if we plot this, we go to negative 2, 4, and notice also that positive 2 gives us a y value of 4, so we can plot that. Negative 1 will give us an output of 1, and positive 1 for x also gives us an output of 1. And then we have 0, 0. Okay, and we plot this. Now this isn't quite a straight line, that's why we call it a parabola. And if we want to try to get a little bit of a curve to it if we can, and get a nice smooth corner if possible. It's kind of tough to do sometimes. And then this parabola will continue into infinity in the positive y direction. Okay, now this point at the bottom is our vertex. Notice it's at the origin. Also notice that we have a line of symmetry here, the y-axis. If this were drawn real well on a piece of paper and then we folded the paper along the y-axis, the two halves would line up on top of each other. So notice that anytime we have b equal to 0, such as here, here, and here, our vertex is going to be somewhere along the y-axis. It's going to depend on the value of c in that particular case. And so here we have our basic parabola, and now let's see what happens when we change the value of a and or the value of c. So in the second case, we have 1/5 x squared. So we already know the value of x squared for each of our values of x. So now we simply take 1/5 of those. So instead of having 4, we have 1/5 times 4, which is 4/5. And instead of having 1, we have 1/5. Now at 0, we still end up with 0. And again, we're going to have that symmetry here, so we get 1/5 and 4/5. Okay, so we have at negative 2, we're not even up to that first line. We're at 4/5, so you have to basically estimate, do your best there. And the same thing at a positive 2. We're at 4/5. At negative 1 and at positive 1, we're at 1/5, so just a little above the x-axis. So something like this. Try to at least be even on the two sides as much as possible. And then of course our vertex is at the origin. And so notice we still have a parabola, but it's much wider. It's been flattened out basically. Okay, and this is what happens when you have that leading coefficient a with an absolute value of less than 1. So 1/5 or a negative 1/5 would also give us a wide parabola. All right. Still have the vertex at 0, 0 though. In our third example, now we need to take -2 times these values of x squared and then add 3. So for x equal to -2, we have -2 times -2 squared plus 3. And of course -2 squared is 4, but then we take -2 times 4 to get -8 plus 3, which is -5. So this is -5, and for +2 it's also going to turn out to be -5 because we still get 4 when we square +2. Now when we square -1, then we're going to have -2 times -1 squared plus 3, which is equal to -1 squared is a +1 times -2 is -2, so -2 plus 3, which is equal to 1. And the same thing happens when x is +1. Then for 0, our vertex is not at 0, 0 anymore, because when we have 0 for x, we have -2 times 0 squared, which is all 0, but then we add on that 3. We tack on that 3 at the end and end up with 3. So our vertex has moved up 3 because of the value of c. So the vertex is at 0, 3. And then we have points at -1, 1 and +1, 1, +1. And then -2, -5. So all the way down here. And +2, -5. Okay, so a couple things have happened here. So we still have our parabola here. We try to make that nice, make that nice and smooth and curvy as much as possible. Okay, so a few things have happened. First of all, this graph is a little bit narrower than that blue y equals x squared. And that's because the absolute value of a is greater than 1. The absolute value of -2, of course, is 2. And so being greater than 1, it causes this graph to drop down more quickly than it otherwise would have, and the graph becomes narrower. Another thing that happens is because that is a negative value for a, the graph opens downward. And now our vertex, instead of being at the bottom, is actually at the top of our parabola. It's our peak. And then the third thing that happens is the vertex has been shifted up 3 units, again because of that value of c. Now if you want to look at these on a calculator and compare them, we can go ahead and graph those. We have y equals, our initial graph was x squared. Then our second graph, we have 1/5 x squared, so you can either put 1 divided by 5 in parentheses, or you could convert that to a decimal, 0.2. And then in our second, or finally our third example, not our second, our third example, we have -2x squared plus 3. And then when we go to graph these, it's going to graph them in this order. So we'll see this graph first, and then this graph second, and then finally this graph. So we graph, and there's y equals x squared, and then the wider y equals 1/5 x squared, and then there's our -2x squared plus 3. So it opens downward. The vertex has been moved up 3 units, and it's a little bit narrower than that y equals x squared graph. Okay, so those are basically the keys to this section. If you can follow that part, the effects of A and C. So in number 2, compared to, there we go. Compared to the graph of y equals x squared, what would be the appearance of? So in other words, relative to that basic parabola, how would this compare? Well, 4x squared, that 4 is greater than 1. This means this is going to be narrower than y equals x squared. Okay. Absolute value of a is greater than 1, so that makes it narrower. In number 2, y equals 1/5 x squared. We actually already saw that, and we know that this makes it wider. So you have the absolute value of that coefficient a is less than 1, then it's going to be wider. So wider than y equals x squared. And then y equals negative 3x squared. The absolute value of a is 3, so it's going to be narrower than y equals x squared. And it's going to open downward because a is negative, so it opens down. And then y equals 2x squared minus 4, this is going to be narrower. Absolute value is greater than 1, so it's going to be narrower than y equals x squared. And it's going to open upward just like y equals x squared. That doesn't change, but the whole graph gets shifted down 4 units because of that value of c. Okay, so it's going to open up, it's going to be narrower, but then the whole thing slides down 4 units. So shifted down 4 units because c is negative 4. And if you were to make a table of y equals x squared and then y equals 2x, or sorry, y equals 2x squared and then y equals 2x squared minus 4, you would find in the second case that every value for a given value of x, every value of y would be shifted down 4. You can do that on your own if you would like. And then finally, number 3, give the coordinates of the vertex of each graph and then tell whether the parabola opens up or down. So if you look at all of these cases, remember b is equal to 0. When b is equal to 0, the vertex is always going to be along the y-axis. And so the x-coordinate of the vertex will be 0. The y-coordinate of the vertex is simply the value of c, negative 2. So the whole graph gets shifted down 2 units, which means the vertex was shifted down 2 units. Instead of being at the origin, it's at 0, negative 2. Now because a is positive, this graph will open up, or upward. In the second example, 2/5 x plus, that should be an x squared, sorry. And this should be squared, and this should be squared. Oops. So 2/5 x squared plus 6, this is going to be wider because the absolute value of this coefficient a is less than 1. It's going to be wider than y equals x squared. And it's going to be shifted up 6. Sorry, we're worried about whether it opens up or down. It opens up because a is positive. In the third example, y equals negative 5x squared plus 4. Here we have an absolute value of a that is greater than 1, so this is going to be narrower. So ignore for a moment the fact that it's negative and just focus on that 5 compared to 1. 5 is greater than 1, so it's narrower than y equals x squared. And it's going to open down because a is negative. So it opens down. And then y equals negative 8x squared minus 1 is going to be narrower because the absolute value of a is greater than 1. So narrower than y equals x squared. And again, because a is negative, it's going to open down. Okay, so for now, if you can grasp the idea of a vertex and noticing the different effects that A and C have, then you're off to a good start with graphing parabolas. Good luck.